Hi everyone, my name is Saika Najwa, and in this video we're going to talk about heat flow with the submateria, ways of heat transfer, Fourier's law, and thermal conductivity. Definition of heat. Heat is when the energy of a system changes as a result of a temperature difference between the system and its surroundings. So, heat flow is product of thermal gradient and thermal conductivity of earth materials. In other words, we can say that heat flow is the rate at which heat rises from the earth's interior up to the surface. Do you know what is heat energy made of? Heat energy is the result of the movement of tiny particles called atoms, molecules, or ions in solids, liquid, and also gases. There is three types of heat transfer. First is conduction. Conduction is the transfer of heat through solid materials. For example, heat generated inside enclosure is transferred to the outer surface by means of conduction. 2. Convection. Convection is the transfer of heat from a surface by means of a fluid and gases such as air. 3. Radiation. Radiation is a process where energy is radiated through electromagnetic waves. This is a few examples of the source of heat energy. Next is the definition of the Fourier's law. Fourier's law states that the negative gradient of temperature and the time rate of heat transfer is proportional to the area at right angles of that gradient through which the heat flows. Fourier's law is the other name of the law of heat conduction. This equation is called the Fourier's law. The quantity lambda is the coefficient of thermal conductivity. And last but not least is thermal conductivity. Thermal conductivity is a measure of a material that shows its ability to conduct heat. So, the thermal conduction is a transport phenomenon in which a temperature difference causes the transfer of thermal energy from one region of a hot body to the same area at a lower temperature. The coefficient of thermal conductivity is the amount of heat that passes through unit surface per unit time at unit temperature gradient. The higher the value of lambda, the faster the temperatures in the system equalize. Thermal conductivity is a property of material. Now, I will find the solution for this example. To find the solution, first we need to determine the change in volume delta V times A. Change is always the final value minus the initial value. And now we can use the definition of work to determine the work done. Now we can construct a conversion factor from the relationship between liter, atmosphere, and joules. So the answer is mean 351 joules. I think that's all. Thank you so much for watching.